Welcome everyone. Can you hear me all right? Can you see my slides? Awesome. Let's go. I'll do my best to keep an eye on the chat during this webinar. So to begin with, again, welcome everyone to this quick and hopefully well presented Docker 101 webinar for Topcoder. My main aim here is to present very basics of Docker, especially focusing on the needs of Topcoder members. My main purpose here is not to present you with exact lines of code to memorize for any particular project, but rather demystify Docker so that when you are faced with a project that requires the usage of Docker, such as a Topcoder competition, you will not be afraid to start tackling the problem, but rather will feel enabled to look into what you need to do to accomplish what you need with Docker. And to accomplish that, I will go through the main concepts that you will need to understand to work with Docker containers and with Docker technology. One of the main drivers that brought this whole webinar about is the fact that we have been running these so-called rapid development match competitions at Topcoder for a while now. And for these competitions, some very basic knowledge of Docker is actually a prerequisite. You will not need to be an expert, and everything covered within this webinar will definitely be more than enough to start competing in these kinds of challenges. And I will actually use a few of examples directly taken from some of these RDM competitions during this webinar. I will not dive into the technical depths and details of what exactly is a container and how they are different from, let's say, virtual machines. I will not go into the details of Docker networking and things like that. You can dedicate a whole full-length course fully on Docker and the internals of Docker. I will not go into these details, but will rather focus on the main high-level concepts aimed at demystifying Docker, especially for Topcoder members. And with that, I say we are ready to begin. And please, as you may receive any questions during this talk, please just write them in the chat. I will do my best to follow the chat. And as my slides only contain material for approximately 35 to 40 minutes, I will do my best to hold a quick Q&A session after these slides. So let's go. This is the main high-level structure of this webinar. This webinar will consist of approximately 3 main parts. The first part will cover what Docker really is, what are the main concepts that you will need to understand to start using Docker technology. Next, we will proceed to a quick overview of what it means to work with Docker, what kinds of commands or what kinds of code files you need to write or understand to work with Docker, and what kind of command line tools you need to work with these kinds of files. And then last, we will proceed into a quick overview of the different kinds of Topcoder challenges where usage of Docker is required, and all the different possibilities that knowledge of Docker will open up for you as a Topcoder member. And throughout this talk and throughout these 3 different parts of this presentation, I will actually focus on usage of Docker through this so-called Docker Compose. And I will go into what Docker Compose is and what this tool is and how you can use it. And for those who already have some background knowledge of Docker, this means that I will not go through in detail the numerous Docker commands themselves, such as Docker run and Docker build, and I will focus on Docker Compose, which is a tool that makes Docker even easier. So we will begin with this heavy theoretical part with lots of difficult keywords for you to at least familiarize yourself with. You don't need to memorize them, but they are what you need to know in order to start learning more about Docker. So on a high level, Docker consists of multiple different technologies. And before we go into any of these, the main concept that you need to understand is the concept of a container. So I believe all of you are probably already familiar with the concept of a virtual machine. Many of you probably have used and do use virtual machines on a regular basis in your work within IT. For example, you can use a virtual machine to run a development-focused Linux on your main computer or something like that. And what a virtual machine is basically a full machine operating within your host machine. So you can have your laptop running Mac, let's say, and then you can run a Windows machine or a Linux machine within that laptop in order to do development for Linux, for example. Docker utilizes containers, and containers are very much similar to virtual machines. I will not go into the details of what exactly are the differences, but the main difference is that containers will be able to utilize some of the really low-level fundamentals of your machine. So they are not as sort of encapsulated within their own unit as virtual machines are, but they will be able to share some, let's say, kernel level resources with your host machine. And this is the main abstraction that Dockers use. So the Docker container is the main concept that you will really need to familiarize yourself with. And then how does this work in practice? And that's what these keywords listed here entail. So the main technology running within the background as you are using Docker is the so-called Docker daemon. You will almost never need to interface directly with the Docker daemon, but the Docker daemon is basically like your virtual box, you could say, if you want to compare with virtual machines. It is the thing in the background that manages these containers and runs them for you. It is the tool that allows these containers to be created and run within your machine. But as I said, you will never need to directly interface with it, but rather there is the Docker CLI, the Docker command line interface that allows you to interface with the daemon. And the Docker CLI is what allows you to then create machines yourself, create these different containers. There's also, I believe, some versions of Docker that have an actual graphical user interface, but I will not go into any of those. But okay, so where are we now? There's this theoretical construct, the daemon, that can run these containers on your machine, and there's a command line interface that you can actually use to create these. How does that happen? And here these different concepts come into play of Docker image and then the Docker container. A Docker image is basically a recipe. It's like a template for such a container. And remember, container can be thought of being similar to a virtual machine. An image is basically a recipe for what kind of machine do you want. As an example, there can be an image for the latest stable Debian release for Debian Linux. Or there can be an image for, let's say, the latest stable Debian Linux with Python and Django installed on it. But that image is in itself not yet any instantiated container. It is just a theoretical set of steps to actually construct such a machine. And when you have such an image, you can instantiate it. You can use Docker to then create this machine on your host machine. And that's what the Docker container is. A Docker container is an instantiation of such a Docker image. And again, you can think of it as something similar to a virtual machine running on your machine. Then there is the concept of Docker registry. Docker registry is a place that actually can host these kinds of images. So you will never need to start from scratch. For example, Docker officially hosts this thing called Docker Hub. And Docker Hub contains hundreds and thousands of different kinds of Docker images. Even Topcoder has many of its official Docker images for many matches hosted there. So a registry is a place that hosts these images. And next I will mention these two additional tools that help build on Docker. Docker Compose is the tool that we will be focusing on here, Docker Compose is a great tool for managing multiple different instances of Docker containers. So let's say you want to develop a web app that consists of 3 different servers. There's your backend server, there is a database server, and there is your front-end server. You can think of all of these as requiring their own Docker containers. So theoretically, they're like their own servers running these things. With Docker Compose, you can easily manage the whole app consisting of these 3 machines. And you can start this whole app and take it down with just single commands. And a Docker Swarm is an orchestration tool that allows you to combine multiple different machines to act as one single Docker server. But we will not go into Docker Swarm in detail here, or any of these other orchestration methods that are nowadays popular. But okay, that's quite a lot of theory and new keywords possibly. So let's go back to the question of why. Why do we want to use Docker? What's the point? Why do I want to learn all of these different new keywords and these new abstractions? What use is it? What value does it bring to me? What value does it bring to any business? What's the point? And for this, we can actually think back to what Java was promising back in the day. We can do machine and platform independent development. If you are, let's say, web developers or something like that, you may have run into a situation where you're developing apps in, let's say, Node.js, and then you start working on some other app with some other team that uses different versions of Node.js and has different versions of all of your dependencies. And maybe if you installed everything globally on your machine, you may start to run into issues because you're getting dependency conflicts between different projects. With Docker, you can focus all of your development into the actual image, into the actual container. So when you're installing dependencies, when you're installing whole programming languages, you can install them only within that particular container. So you will be able to fully avoid the problem, or even the chance, the theoretical opportunity of really messing things up on your own host machine. You can do, let's say, Ruby development, you can do Node development, you can do Python development without ever having to install these programming languages on your own machine. Rather, you can just create your server directly and install it there and run it within a container. An additional benefit is that you will be able to develop software as a team. You can host your whole Dockerized server. So let's continue with this example of a web app. So you can host your whole backend server with the Docker file that defines it, with the definition of the Docker image, and with all of the code required to actually run this backend server. And you can put it all on, let's say, a GitLab or a GitHub repository. You can develop this whole server together within your team. And anytime any member of your team wants to run this server, it will run the exact same way, because all of the dependencies, all of the configuration is already packaged into that one image. And that's obviously a huge benefit, considering the fact that you might otherwise have all sorts of different configurations on your own personal machines. And this leads to us to the concept of CI/CD. You may have heard about DevOps, and you may have heard about these concepts of continuous integration and continuous deployment. And for these, due to the reasons I just explained, Docker is hugely beneficial, because you will be able to develop whole systems as a whole within your team. And if you're hosting these things on a particular GitLab or GitHub repository, you will also be able to configure scalable and automatized ways of continuously integrating these codes, or even deploying them just with the push of a button, without having to do manual server configuration or manual deployments anymore. And again, this leads us even further. Now that we are able to do these kinds of abstracted development directly to a server that can be developed anywhere or pushed anywhere, deployed anywhere, that has Docker, this enables us to do cloud native development. We can develop our different backend and front-end database servers directly ourselves on our machines. We can run them and test them on our machines. And with the push of a button, we can deploy them directly into the cloud. And this is the premise of cloud native development. Docker is a truly fundamental building block of this kind of development. And again, once everything is running in these kinds of easily managed containers, we will be able to configure even larger scales of abstraction. We can automatically manage our servers. Let's say your database server has a tendency to crash sometimes. We can add some sort of watchdog utility to see if the container itself crashes and do an automatic restart anytime something like that happens. And similarly, because everything is hosted on everything is hosted in the same way, because everything is running in a container, we will also be able to do log management and monitoring in a centralized way. And this enables us to build dashboards. Because everything is running in a container, we can do the same thing for every single container to collect the relevant logs that we want from them into another machine, into another container. And thus we can collect also the usage logs, and we can use get the real-time usage status from all of these, and we can build dashboards. All of these are aspects of modern cloud native development. And in heart, what this enables is true scalability. If you stay up to date on, let's say, microservices, technology news and things like that, you may know that some of these true giants of these of modern technologies, of modern tools, the places like Netflix that use microservices, they can have systems that consist of hundreds or even thousands of different microservices. And what these microservices are in heart are deployed containers and sets of containers. And of course, this leads even further. So as I was just talking, this enables this kind of true enterprise level development with the microservices architecture that many software giants of today are using. And truly, can you imagine how creating something like Netflix without using something that is truly scalable or automatically scalable and manageable? I don't think it would be even possible. So containers are the one way to enable that. Okay, so that was all high and mighty and so on. So let's get back to the actual machine level. These are the things that I already talked about a little bit. So on your own personal machine where you are running a Docker daemon, a Docker service that can run these Docker containers, these are the things these are the benefits that you will be able to realize. You can avoid dependency hell on your machine. You can develop all kinds of different systems. You can simultaneously develop systems using different versions of the same languages and runtimes. You will be able to simulate networks of multiple servers on your single machine. As in my example of a web app where you have a database, a backend, and a frontend, you can have all of these machines being their own containers, and you can simulate the network that they create on your own machine. You can even simulate the network so that the database is not accessible to anyone but the backend, and the frontend only communicates with the backend, and only the frontend is accessible outside of this particular network, and things like that. And as these are actual servers, and servers have their own configuration that needs to be done, you can save this configuration, and anytime you start your server, you can load this exact same version of the server configuration. So anytime you restart the server, it will be the exact same as the way you planned it and the way you created it. So there will not be a case of you manually logging into your server, doing some configuration, maybe late at night, and then waking up next day and realizing that, oh no, something really broke, and now you don't know what to do. It can never happen. This is now not a possibility anymore at all, because everything is running in these containers, and you have a saved ideal state that you can reload anytime you want. But okay, if everything restarts just the same every time, how does my database work? Does it get wiped out every time? No. We also have the ability to persist data by using these kinds of shared volume mount folders that are shared between your host machine and the container. So what you can do is you can make it so that anytime you restart, all of your configuration stays the exact same, gets reset, but only the data, the actual database itself, the data will persist, and the data will stay on your host machine. Anytime you load up your database server, all of the configuration will be in your saved ideal state, but the data will always contain all the data that you ever put there, even if you restart. Well, okay, and how can we accomplish this? That's a lot of all kinds of cool benefits. That's so much cool stuff that you can now imagine doing with this Docker technology and all of these superpowers that we've now unlocked. How do we do that? So in practice, it's quite simple. There's this concept of something called a Docker file. A Docker file defines a Docker image. It is the recipe that defines how to build a particular server. For example, a Docker file can say, take a Debian distribution and let's say do this configuration on it, set these environment variables and download Python. That's an example of a Docker file. Then we invoke the Docker CLI that I talked about, the command line interface to Docker, to actually build such a Docker file. When we call Docker build, it builds an image from that Docker file. And once we have that image actually built, we can instantiate it by calling Docker run. Docker run will take a pre-made image and then actually create this kind of actual running Docker container from it. And that's it. Those are the steps needed to actually run this kind of Docker machine. Good question, Jay. And yes, I think that's my next slide. Yes, so let's look at an example. And these examples that I'm using are actually taken from an RDM competition at Topcoder. RDMs are rapid development matches that focus on some very basic software development skills, backend development and front-end development. And due to some technical requirements, all submissions are required to use some Docker. But luckily, we always provide sample submissions that already have the Docker file written for you. So you don't need to worry about the details of Docker when submitting these RDM submissions. This is an example of a Docker machine. It is actually the sample submission for a particular RDM. I hope you are able to read the text. As we were preparing for this webinar, just a few minutes before we started, we realized that the font size here is actually quite small. So I apologize if you can't read all of the details of the text, but I'll do my best to focus on high-level concepts anyway, so that it doesn't matter too much if the text is too small for you. But hopefully, within this particular folder, you should be able to see a few different files. There is a folder called public. There is a file called Docker file, which is the Docker file I just talked about. Then there's some JavaScript files and some Git files. There's an index.js, there's a package.json and a README, and then some Git ignore and Docker ignore files. So what you should be seeing here is that there's a Docker file, and then there's absolutely everything else. Why is that? Because the Docker file itself defines how to build an image, and all the other stuff is stuff that probably likely goes within the image and will be run within the image. So the Docker file here is a special file, and everything else is something related to the app that you are writing. In this case, the sample app within this particular competition. So let's open up this Docker file. Again, I apologize for the small font size, but I hope at least some of you will be able to see the text a little bit. This consists of just a few lines of code. Docker files have their own syntax, and you can Google for it if you ever need to modify or even write from scratch your own Docker files. But the syntax for these files is actually quite simple. So in the first row, there is from, node, and then. What this means is take the pre-existing Docker file that exists somewhere in the cloud, the Docker hub in this case, and take from this registry the node Docker file. The node Docker file is already a pre-made image for you to use. it is a particular Linux flavor that has everything needed to run Node on it. This means there's already an existing Node binary on this machine and all of the dependencies needed for Node. Then the next lines of code are then to take this existing Node machine and then do all of the admin work necessary to run the app. Because as you saw, there was this, other than the Docker file, there was this everything else in this folder, and this everything else is a particular Node app. And how to run this Node app? Well, we specify the commands for that in the Docker file. Now, anytime we run this Docker file, these steps are made, and then you will have the exact same server running every single time that has been built through these steps. So what these commands do is they set the working directory, they copy the contents that we need, they install all of our dependencies, they copy this whole folder into the work folder that we're in. It exposes this particular port that we're running on, 8080, on this machine, and then it simply calls Node. So it calls Node with this index.js that we have, and that's it. So in effect, what this Docker file does is it takes a machine that has Node already installed and configured on it, and then it does the simple administration steps needed to copy these code files into that machine, exposes the port that we need to run this particular app, because this particular app will be running on port 8080. So we expose that port, and then we simply run Node, and that's it. I hope this can clarify some of the mysticism around all of these mysterious Docker folders that some of you may have seen before. This is literally all that there is to it. It is simply a configuration. It's a recipe for creating a server that can run this app. And now this app will be running within this particular container that has this version of Node installed. So the app will not be running on your own machine. And here is just an example of the Docker output when you are actually building this thing. The details here are really not important at all, but you may be able to see all of these different steps. There is step 1, step 2, step 3. And in each of these steps, you can see that, I mean, if you can see the text here, so you can see the different lines of this Docker file that I just showed. So in every step, it takes one line of the Docker file and runs it and creates step by step, creates a container for you that way. And we will actually come back to this example a bit later when we go through Topcoder competitions that use Docker. So now that I've given this kind of first taste about Docker files and how Docker works, we'll return to these concepts of images and containers and introduce the additional new concept of a layer. So what was just going on in these pictures is an image that I already explained about. This image is defined by the Docker file. The Docker file is a recipe for building a particular system, usually a Linux system. And Docker files can and often do build on each other. So as you saw in this previous Docker file, the first line of the code was to take the pre-existing Node Docker file that exists in the cloud. So you don't have to worry about installing Node on a machine, because installing Node and writing an app on it is such a standard task nowadays that, of course, there's going to be a pre-existing, well-made Docker file for that already. So you can simply take that existing Docker file and build on top of that and simply add all the files you need for your app. And here is another example. Take the latest stable version of the Debian distribution from Docker Hub and install Django on it and all of the dependencies needed for it. And oh wait, that's actually what the official Python Docker image does nowadays. So if you write from Python and then a version number, you will get a distribution that has Python, including Django, already installed on it. And it's based on Debian. But there's also different varieties of it based on other Linux distributions. And now that we have this image defined by the Docker file, when we actually build and run it, we are creating a container. And as I mentioned before, a container is an instance of such an image. So when we build it, we will actually build the image into an actual container that we can run. And this container is the analog of a virtual machine that can be run on your computer. And now here comes an extra concept again, that this is sort of information that you will probably not need in your daily life if you use just a very basic Docker systems. But if you end up using Docker heavily, this is something that's important to know. These different steps of the Docker file, as you are building it, they go through intermediate layers, and each of these intermediate layers is actually its own image. So Docker actually creates different images for some of these different steps in the Docker file. So this can help you optimize when you are creating different Docker files. And if you are constantly rebuilding and modifying your things, it means you can sometimes end up with a bunch of unused images on your machines, and they can sometimes take up some extra space. But this is not an important concept at the beginning level. It's just something to keep in mind that when you are building a Docker file and going through all the steps in the Docker file, some intermediate layers and some intermediate images are created. So I've been talking about this Docker Hub. And what is it? What is this Docker Hub? So I mentioned this concept of a container registry before. Docker Hub is a container registry. There are a few other container registries, but Docker Hub is the official one and probably the biggest one as well. A registry is a place that can host images. And these images are actually organized into different repositories. So you can think of Docker Hub as, let's say, GitHub. And then within Docker Hub, you can create your own repositories. For example, Topcoder has its own repository. And each of these repositories contain different image definitions, different Docker files, so to say. So for example, different Topcoder marathon matches that have automated testers and so on, they have their own images uploaded on the Topcoder Docker Hub account on the Docker repository. There are also different container registries, such as Google and AWS, that have their own. And it is also possible to configure private registries if you are, let's say, developing within an enterprise and you want to keep your image definitions trade secrets. And now we get to this main tool that we will be using in our following examples. I mentioned Docker Compose before. Docker Compose is a tool that allows you to not have to think about all of the different particular Docker commands that you might have to run in order to manage all of these different Docker containers on your machine. Docker Compose is a tool that allows you to abstract away from that at the cost of learning Docker Compose, of course, which is a quite simple tool, luckily. So Docker Compose allows you to manage multiple containers. It allows you to manage apps that consist of multiple containers, such as this web app example. Each of the Docker containers that you need for your app can be defined as their own images and as their own containers, and each of them have their own Docker files. So I showed you the example of a folder defining a Docker machine earlier. So you might imagine that each of your servers, the backend, the database, and the frontend, each have their own folder similar to this, and each of these folders has its own Docker file. And then as you want to run the whole app, you will need all of this running. So there's two options. Either you manually go into all of these different folders and manually run all of your different images, which you can believe can be cumbersome, or you can use Docker Compose. Docker Compose allows you to create a single configuration file that holds all of the information needed to run these different Docker machines. Just this one configuration file with all of these machines, and then you can give that file to Docker Compose, and then this Docker Compose command line tool will run all of these machines for you. And here's some slides I stole from the official documentation site for Docker Compose. It is let's say, a fully developed tool that has all kinds of different features and for the main usage of just running multiple containers on your machine. You don't necessarily even need to know all of the features, but it does support, let's say, working between production, staging, development, and so on. And then main steps that you need to understand are also written here. So all of your different components need to have their own Docker files. Then you will create this configuration file, Docker compose YAML file, and then Docker compose app will run the whole app. And then analogously, there is also Docker compose down to take your machine down. And that's basically all of the command line usage that you will need, at least for basic usage. And how do you write these different configuration files? Here's an example. Again, I hope you will be able to read the text. But basically, this configuration file consists of a few different parts, and the main part here is the services. This particular app consists of two different services. There is Redis, and then there's the web server, and that's it. And how do you give this file? How do you give these containers to the Docker compose? Just like this, you write this YAML configuration where you list under services all of the different services that you have to run. If it needs to be built, you can give the different folders that need to be built. So in this case, Redis is an pre-existing image, so you just give it the parameter image, and this image is found on the Docker Hub, because for this particular use case, just the usual Redis image will work. And then in this example, they have their custom web app on the current working folder. So they give the build folder, which will be built. Then they will give the port mapping. This will map the port 8000 to the port 5000. So the actual container itself can host it on the port 8000, and then it will be routed to this. Then it will give the different volumes. You can think of them as shared folders, basically. These are the folders that are shared between this web app and the host machine. So for example, you can see that the logs are persisted between runs because they are sharing the logging folder. And then there is a link which will link this container with the same network with the Redis container. And you really need to write from scratch these different Docker compose files. You can find examples for the particular stack that you are working with, and then do all the modifications you need there. So you don't need to memorize all of the different keywords that you have to write into the configuration. The main thing is to understand what all of the different things do, and what are the main things that you want to do, so you will be able to do modifications. That's the main part for my theory. There's some next steps where you can go. If I'm able, I will put this huge link dump into the chat right now. Yes, I think it worked. These are just some additional tutorials where you can go into extra depth or into extra specialized topics. But okay, my talk is not over yet. I will now go into how does Docker work in Topcoder. So there's a few different ways of actually using Topcoder at competitions. Some competitions may actually have a requirement of Docker. For example, a development match might require Docker because the client wants a Dockerized solution. So there have been some challenges like this in the past. Or there can be an automated testing match, such as a machine learning marathon match or an RDM match that may require Docker, just because the automated testing system that we have in place requires a Docker. And then some challenges may utilize Docker behind the scenes without strictly requiring it, such as the fun marathon matches. Additionally, idea generation and architecture challenges may require Docker, simply because Docker is such an important building block of modern development. So for marathon, there's two kinds of marathon matches. There's the traditional marathon matches, which are heuristic algorithm optimization or competitive programming matches. And for them, I believe Docker is not required for the submissions, but because there is an automated tester, there is Docker used behind the scenes. So anytime you submit your single code file, it actually gets built into a Docker container behind the scenes, and then this container will be used to run the automated testing system. Additionally, there's some machine learning marathon matches. Sadly, I don't think there was a competition like this up right now, so I didn't get any good example with screenshots for this. But some machine learning matches may require you to create a Docker file, similarly to RDM matches. So let's go into these RDM matches that I've been talking about. RDM matches are development matches that require you to solve 3 different problems, easy, medium, and hard. And for each of these problems, your submission will actually be such a Docker folder. It will be a folder with a Docker file and then everything else that you need for your app. And that will be run within the Docker container that is created from this Docker file. And thus, some basic understanding of Docker is required for these competitions, as Docker is used directly for the automated testing system. The benefits of this is that competitors will be able to use any language they wish, because all of the dependencies, all of the actual language binaries and runtimes will be packaged into the container itself and not run on any machine in particular. And thus the automated testing system will be able to take these containers and then run automated tests against the output of these containers. So for example, against the web app that they expose. And as I mentioned, the submission must be this kind of folder that has the Docker file and everything else. So let's go into an example. This is related to the example that we saw before and will again lead back to the example that we saw before. For each RDM round, we will actually give this sample tester as well. And this is the contents of such a testing folder. Such a testing folder will contain 2 folders, the code folder and the tester folder. And then it will contain this Docker Compose configuration file that I talked about. And then there is the README. So of course, the good first step is always to read the README. So what does it say here? Okay, this README gives us the command that we need to run Docker Compose so we can test the solution in a similar way as the actual automated testing system itself does. What we need to do is we need to call Docker Compose up with the parameter or with the flag build. This means the system will build the Docker files and then the up command will actually run the containers. So presumably at this point, we can guess that the Docker Compose file contains the definitions on all the configuration needed to run the 2 different Docker containers here. The 2 containers being the tester, that is the sample tester that is given to us, and then the code folder, which contains our solution. And okay, once we are running it, there's another command that we need to run. So we have to take down the currently running containers and then rebuild and run them again. So at this point, what I would do is I would just copy this command and then put that in my command line. So I could just use the same command all the time without having to retype it. So let's have a look at this Docker Compose file here. Again, I hope you are able to read this, but as you can see, it's a simple file. It contains the services part that I showed before, and under services, there's 2 different definitions. Like we guessed before, there's the solution container that will be built from the code folder, and there's the tester container that will be built from the tester folder. For the actual solution, we want to expose some ports. So we want to expose this port 8080, and we will map it to 8080, so we don't change the port in this case. And then we will run the tester as well. And we will use this depends on configuration flag here to mean that once this code folder is successfully running, this dependency is satisfied, and then this tester will be run after that. You don't really need to care about the configuration for this tester because all of this will be given in the challenges. you may need to care about some of the configuration for this, at least if you want to view the output of the Docker container on your own machine. For example, you may want to, if there doesn't exist this line expose, you may want to add this expose port so that this particular port will be exposed to the host as well. That way you will be able to view this port 8080 from your host machine as well. And now once we have run this Docker compose command that we just saw in the README, this is what happens. There is this output that you saw before where the machine will be built, and then we will see this nice line here. Solution container, app has started listening on port 8080. That means we have been successful, and now the current solution within the code folder is listening on port 8080. The app is being served there. What happens after that is, because this dependency is now satisfied, the tester machine will now be built and run. And how these testers work for RDM matches is that there is a list of different test cases, and then you will see the output of these test cases. If it is successful, there is this green check mark. If it fails, there's a big red X. So in this case, we have our solution and the sample tester that have some sample tests, and we will see that, yay, great success. Some of these test cases are passing. But because it's only the sample and our solution isn't yet correct, there's going to be one big red X as well, because there's still some test case that didn't pass. But that's the way to work these sample testers for RDM matches. There's only the one command line command that you need, and it's in the README. And this is the output, and this is how to interpret that output. And now we can quickly look through this example that we saw before. So within this code folder, there is your solution. And now we understand that this solution consists of this single folder that has the Docker file, and then it has everything else which defines your app. The Docker file contains the instructions to build the machine to run your app. So again, here is this Docker file that we saw before. We need a node server, and then we need to set this work directory, and then we just copy our code files into that working directory, expose the port that we want to serve the app on, and then we will simply call node. That is the solution in this case, written in Node.js. If you're using other servers like Django, for example, you will have a different kind of Docker file. And luckily, because serving different kinds of web apps in different languages is a standard task nowadays, you will be able to find pre-existing Docker files online and base your work on them. And here is again this output that we saw before. Once we run this command from the README, we can see these build steps. Each of these steps builds some of these intermediate layers for this particular image. It builds the actual image. And once it is built, it creates a solution container and runs the container. And then at the end, we see this line that the app has started listening. That is how these things work in RDMs. I hope this has demystified a little bit these RDM sample submissions. So we are now reaching the final part. There's a few other kinds of competitions where you might need to use Docker, or you might need knowledge of Docker. You might not actually have to use Docker, but you need to understand it for this. So Topcoder has many idea generation and architecture challenges. In these challenges, you will have to create a basic software architecture or the high-level idea, let's say a business idea for some kind of service. Because we are living in 2022 and cloud-native development is the standard nowadays, Docker is the standard building block for these kinds of development. So to be successful in some of these challenges, you might require knowledge of Docker, so you can design systems that utilize Docker to run all the kinds of apps that you might want to design. Similarly, there might be a hackathon or a free-form development match. For example, in the last year, within the LF program, there were a few machine learning development challenges where the contestants were required to submit Dockerized solutions. This was so that the client could easily test and replicate the output of these solutions themselves. And thus Docker was needed for these particular development challenges as well. So as I mentioned, because Docker is the standard building block of modern development and modern DevOps, knowledge of it will be highly successful in many parts. And here's my final note. If you know Docker, you can just go on Topcoder and find so many different gig work opportunities for yourself. You can use Docker, and you can find many different gigs for that. Or you can search these related technologies, such as DevOps, which in my experience relies a lot on Docker. Or you can search for Kubernetes. And Kubernetes, I didn't talk about it yet, but it is a system that builds on Docker. So it allows you to build even bigger systems that contain many different containers, many different Docker files, many different Docker systems. And Kubernetes allows you to create and manage these kinds of big systems. So you can simply go on Topcoder and search for gigs requiring these kinds of Docker technologies, and there will be so much work, and you can make a killing for yourself there. Okay, that's it. That's it for my slides. Apparently, it was a bit longer than half an hour to 40 minutes, but I'm happy that I'm right on time. Here's a quick listing of some of the things that I didn't consider here. So if you want to delve deeper into Docker, these are some of the topics that you can start Googling for. So that's it for me. I will now check the chat if there's any questions. And if you do have any questions or feedback, please just write it in the chat. Okay, great. I see that there's no questions so far. And yes, one person asked if this video will be accessible later. We will be posting this on YouTube, so you will be able to refer back to this video. Excuse me. Oh, it seems that there are a few unanswered questions in the Q&A tab. Is it possible to bring these questions on the screen somehow? From where I learned Docker, I basically learned Docker through practice. I was a software developer. I needed to use Docker for my project within my team, so I just had to learn Docker. That's how I learned it myself. I personally didn't take any courses. I just did what I needed and learned what I needed. But there are many really great courses for Docker, even openly accessible online. So I do recommend those if you want to learn more. Okay, and how do you decide between Docker Compose versus Kubernetes? Well, I'd say this question has a few aspects. When you are developing yourself, when you are like creating your prototypes on your own machine, I would say just use Docker Compose. Once you already have some kind of working proof of concept app for whatever product you're developing, once you already have a plan for what different code bases you need, what kinds of different systems you need, and then you decide that you will, for your business needs, you will need heavier duty managed platform. At that point, you can make the decision to use Kubernetes for it. But I mean, it's also up for preference. You might prefer Kubernetes if you have like already heavily used it in many different projects. In that case, of course, it will make sense to just use Kubernetes from the start. And I see Victoria has a question about the local testing. Maybe I can go back to that slide still. So here we are at the starting point for the local tester. This is the folder that we have downloaded. There is the code folder and there is tester folder. And then this top level folder has the Docker Compose and it has this README. So we open the README, and the README tells us the command that we need. So on the first run, we will just need this command. And then for any subsequent runs of the tester, there is this command that we need. So we can simply copy paste these lines into our command prompt, and that's it. And this is the output, what happens. You can see at the top, I have copy pasted this line of code. What it does, it builds the code container. Once the code container is running, it then builds and runs the tester container. And then we get this testing output part. Does that answer your question? Yes, the tester is run automatically with this command in the README. All you will need to do manually yourself is actually develop your app, of course, and then copy paste this command into your command prompt. Okay, great. Any more questions, or are we done here? I hope I have been able to demystify Docker a little bit. I know that due to all of the different concepts that you will have to learn to approach Docker, it can be quite intimidating at first. But once you get to the heart of it, it is really quite simple, and the benefits it offers are really huge and definitely worth learning it. Yes, of course, do join us on Discord for the after party event. Okay, I think with that we are done here. So thank you everyone for joining. I had fun. I hope you had fun too, and I hope I was able to demystify Docker a little bit for you. See you next time and have a great week.